Hello everyone and welcome to today's webinar from the Trimble Track Survey and Scanning Group, part of Geospatial. This is Stefan Lutz speaking and my colleague Linas is with me, and we are going to share the presentation today with you, and let's get started. So this illustration shows all the rail infrastructure applications we currently support with our Trimble GEDO system. And today's presentation is focusing on the scanning functionality of our system, particularly scanning involved in the design phase, in the asset data collection phase. Then when the track is built and we do as-built surveys and document what has been built with a laser scanning system, all the way to looking into the clearance application. Clearance analysis is an important functionality that is done usually throughout the life cycle of a railway infrastructure project, not just for the installation, but also later once the track is built and modifications are done, or throughout a certain maintenance schedule where the track has to be scanned and clearances have to be analyzed. So to do that, we are happy to introduce a new system today, the Trimble GEDO GX50 laser scanning system, specifically made for kinematic clearance analysis and asset data collection, and having in mind all the railway specific functionality, and the system is highly flexible. So as you can see, this is not just a piece of hardware that we are going to introduce today, the scanner with the scan heads. It also includes the field software solution and the office software solution to extract information from the scan data in the field. So I will cover the first chapter, which is a system overview. I will introduce to you what the system is, what it does, how you can configure the system, and some technical specifications. Then I will hand over to my colleague Linas, and he will talk about the field scan procedure, the workflows, and the analysis from our scan data, including how to extract deliverables from the scan data. Finishing off with a summary, and then we will take some questions and we provide some answers. So if you have questions, please start typing them in. We will go through the questions at the end of this presentation. So starting off with the system overview, we have our GEDO CE2 trolley system, and based on that trolley system, we can add the so-called main unit that comes with the power supply and data storage. That main unit functions as the carrier for the scan heads. Can be one or two scan heads. We'll look into those configuration options in a few slides. So they're connected using some special made clamps onto this main unit. So they will power it from there. There's a few cables to provide the scan data into the data storage units, and the whole system fits into a transport box designed for the GX50 scanner system. Looking into the scan heads, it's a changeable system with one or two scan heads. The scan heads are made with a long-term calibration, so they don't have to be calibrated in the service department for quite a while. The scanner, depending on if it's a single or dual head configuration, have a rotation speed of 120 rotations per second, or 240 with a dual scan head solution. The measurement frequency is either 500,000 or 1 million. We have some flexible mounting solutions here with the so-called fix and lock installation clamp. So they will allow the user to bring the scan heads into a very specific orientation. Of course, that orientation is supported in the field software, and then the scan can be done with this dedicated field software. The system comes with USB data communication and Wi-Fi, We use the same S-series batteries that we use for the complete GEDO system, with the same batteries we use for the total station and for the GEDO CE 2.0 trolley. One important thing to mention is also that the scan system is rated to IP65, which is a very high rating for a laser scanner. And we also were able to extend our temperature operating range from -20 Celsius to +50 Celsius, which is also unique for that scan system here. So this slide provides you with an overview of the different configuration options, starting off with a single head laser scan configuration, which is an entry level configuration with one scanner. If you have the the dual head scan configuration, they can be mounted in a 90-degree orientation. That 90-degree orientation is optimized for the highest accuracy you can achieve. We also have a setting where the dual head can be configured into an 80-degree configuration orientation, which provides a very good object visibility because you see objects from a bit of an angle, which also provides you with a very high measurement accuracy. The dual head butterfly configuration is made to optimize for visibility because of the orientation. We capture objects from the side and have a very good visibility, especially for thin objects that would otherwise be not seen in much detail. And we go into examples and show you some slides how those configurations, how those images will look like. So here is an example. We took the top view of the rail with a single head configuration to the left and a dual head configuration with a 90-degree orientation to the right. So you can see that with a single head configuration, there's a little gap here in between the rails. And if you look into the level of the detail on the right picture, you can clearly see that you have, first of all, you don't have that strip, that black strip anymore. You have a higher point density and a higher level of details if you use the dual scan head configuration with a 90-degree orientation. The next slide shows you orientations of an example of a thin object like a sign next to the track and a post or a mast. In the left image, you have the dual head configuration in 90 degrees. So basically, you walk by and you capture a certain amount of points of that thin object. If you look into the middle image here with the 80-degree orientation, you can see that the level of the amount of points, the density is higher. This means this 10-degree difference from perpendicular gives you already a better point density and more details of a certain thin and flat object. You go into the butterfly configuration, you have the highest amount of points visible here of the side and the mast. Then here's an example of the dual head 90-degree orientation for a flat object that is perpendicular to the track. The butterfly was a 90-degree orientation, and you can see here that this box, is only visible with some level of details from the side. And in the butterfly configuration, you can see a higher level of detail, and you can almost see two sides of that object from what a scan has been taken from that track. So this is an overview of how you can use the GEDO scan system. This is different configurations for different purposes. The starting point is the pure GEDO scan solution without adding a geodetic sensor. You can get relative positions in that orientation, in that configuration. That's an entry-level solution, but this is one way of a quick as-built to capture the track quality and the scan with a single scan head solution for relative positions. If you add a total station, which is the GEDO Rec and scan combination, Then you have a geodetic solution. You have your total station setup. You provide the trolley system with a high accurate total station position, and from that you have a fully oriented point cloud, and you can take absolute measurements from that. The picture to the right shows also a setup with a GNSS receiver. If accuracy requirements are less, or if there's no control points available, you can combine the GEDO scan system in combination with a GNSS. The highest productive system is the combination of a GEDO IMS trolley with the scan solution, with the GX50. So this gives you a very versatile solution, highly productive in terms of track measurements. You can cover how many track mileage, how many track meters you can measure in a certain time. You have the highest productivity here. If you don't have ground control points, you can also use GNSS to orient or to correct your IMU positions with that system. So to summarize those slides here quickly, this is a very specific application for railway. It utilizes the known GEDO CE 2.0 track measurement trolley system. The same trolley system we had in the market before can be used to add the GX50 system. We have a full 360-degree kinematic scan of the track and the surroundings. It's highly flexible and scalable. Starting with a single head solution, you can add a second head later if needed, and you can put the scan heads in certain predefined preset configurations for optimization of visibility or accuracy. It's very easy to handle. We have a dedicated field software, a dedicated office software that handles all the data in a easy to use field setup. So with that, I hand over to my colleague Linus, and Linus will walk you through the scan workflow and how to process and analyze the data and how to extract deliverables.
Hey, hi, hello everyone. Welcome to the webinar. And today we will take a second part of this presentation and go into the more detailed view on how this new scanner system integrates into the overall process. So the scanner itself is just part of the whole solution. So as we can see, the whole process is much more complex. It involves a field scanning solution like GX50, a field software. Like today, the GX50 can be combined with GEDO Scan and GEDO Rec Scan or GEDO EMS field software, and as well powerful point cloud data processing office suite, GEDO Scan Office. So all this combination brings a very powerful tool from field to the office analysis, and what is very important here is that it's really railway specific. So it's everything is tailor built for the railway purpose, for handling railway infrastructure. So taking a step forward further, we will look into the whole process from field to office, and the field operation itself is scanning, and scanning is not just scanning. It means that we have to prepare the system in the right configuration, which is basically should correspond to the task and to the expected accuracy. So we have to adjust the scanner heads. We have to select the right positioning sensors, and then we are ready to go into the field with a field scanning. So this is one part. We run the scanning, so it's not the process itself. It's not that complicated, so it requires operator a little influence on a workload. And then when data is collected from the field, it needs to be linked together, because from the field we bring the trajectory, we bring the point cloud data, and then depending on a bit on the system configuration, the process has to link. In this processing phase, we have to link the trajectory together with point cloud data. So it can be relative scanning when we get the trajectory a straight line, or it can be the absolute scanning when we get the trajectory as 3D polyline, and then the whole point cloud data is gets the 3D coordinate. After this process is completed, then we have the full data set available for further applications, and then the data can be processed using the automated or semi-automated functionality in GEDO Scan Office, and this at the end will bring us the final result or final expected results and reports. So very important that this is nothing general, this is very specific to the railways. So all the functionalities are very well thought over and implemented just to meet the rail industry standards. So in the next phase, we also have to think about a bit broader, have a bit broader view, because in Trimble Geospatial, we are not alone. We deal with other divisions, and it's important to picture out here that the data flow is not limited just within railways. So we can bring the railway data to the Trimble Business Center, Trimble RealWorks, and do the data classification, filtering, and then bring back data for the railway analysis. So it's really becomes a really strong combination of multiple tools, which allows you just to even further improve and add value to the data. So it's interoperability across the Trimble products, and also not only on the software side, but it's also on the hardware side, that when we come to the railways, we have the station areas, we have the interstations, plane lines, we have metro, and so on. So it's a different infrastructure. Here we can choose between different sensor platforms, starting with terrestrial scanning, when we need to scan just a station or just a small fragment of the track. Or if we think about larger objects, maybe fuel-free or maybe 10-kilometer stretch, we can do the scanning using the Trimble GEDO scan solution. And if we think about the massive project around 100 or maybe up to 1,000 or more kilometers, then we can just use MX platform, MX9 or MX50 system. So different combinations, different tools for different scale of the project. And of course, if we think about the accuracy, so terrestrial and Trimble X7 terrestrial or Trimble GEDO scan system delivers close high accuracy point cloud data, and I mean, this is very critical probably for high precision engineering and design. So from the workflow, let's take a look further into the application. So here we will look at the different applications, and we can basically them divide into 4 major groups. So starting with, we will start from the planning and design, which is probably the booming today, and due to the newly coming BIM standards, the more and more consulting and design offices are interested in different kind of data modeling. It means that having the point cloud data, having the as-built track data, it's possible to do the different modeling of design, conceptual and some different visualizations to see how the new proposed design will fit with the existing infrastructure. So in the planning and design, we think about modeling. Modeling, it means that we bring in the existing extract data and existing infrastructure data, and then do the combination collision analysis. And as well, we also in a planning and design phase, as-built data is really makes a good value for pre-estimation of the material outcome even before the construction has taken part. Another thing in the planning and design, it's also important to know information about overhead and overhead cables and catenary positions. For example, if we're thinking about the replanning the track structure, it's important to know if the clearance between overhead lines and the new structure position will be still within the tolerance limits. So in overall, planning and design is one of the massive areas where the GEDO solutions and point cloud data is used. And then we come to the actual implementation of the design solutions, and here we think about the construction. And then the construction process, we think about as-built control. So as-built control in comparison with what was planned is probably a key element here, key application. And also we have the platform verification. So it's again, we think about as-built control. We also here check the material quantities and volumes. So we check what was the outcome and if it corresponds to what was planned. The same here concerns with the heights and staggers. So if we place a new, install the new overhead lines, we also think about if the stagger positions are corresponding to the initial design position. And of course, during the construction phase, it's also always important to monitor the live clearance. So the GEDO, new GEDO scanner solution is extremely effective to run the live scanning as it generates extremely fast live scan data, and it is very useful to monitor the live clearance at a fragile position. So for example, if we have some live traffic, if we have some other areas which can cause potentially a hazard to the surrounding environment, we can always run the system and check if the clearance is intact. So going from construction, we transitioning to another area, which is probably one of the largest. I mean, in a structural life cycle, the maintenance and operation. So in this stage, GEDO systems, GEDO scan system is used especially for the clearance inspection during the operation. So we can here talk about the regular periodical clearance check. And also, if we have a new train type introduced, so we can do some preliminary or in advance verification if the new trains will be compliant with the current corridor clearance. As well, if we talk about the metro systems, here we have another interesting topic. It's a third rail monitoring and overhead lines cabling monitoring. So it's about the deficiencies. As these structures has a trend to move and deformate, then it's important to know how far they are off the, so to say, designated position, and if there is needed any actions to run the maintenance and special procedure with repairs and so on. So from the maintenance and operation, we go further to the rail asset inventory, and here the GEDO systems are used. The GEDO scan system is used on a less, let's say, put it this way, on a smaller scale project. So if we have the GIS system and it requires some maintenance, so the GEDO scan solution is very efficient to run scanning on those areas, on those track areas with the recent changes. So it's let's say from 1 maybe up to 10 kilometers in length, and collect asset data. So we can just update the GIS databases with new changes. We can also update GIS databases and asset databases with new data, with condition change about the assets, for example, some defects and so on. And also, this can be used to create some new work orders. For example, if the conditions of the data assets are so much deviating and decreasing, then of course this GEDO scan solution will be a perfect tool to bring this data and convert it into the use it as a tool to for upcoming work orders. If we talk about the large-scale projects in asset data collection, of course, the MX9 and MX50 platform on mobile mapping system is probably the way to go, because with this we can collect a massive amount of data on a large-scale, let's say, projects which are 100,000 kilometers in length. So further, let's take a look at the deliverables. So let's take a look at the functionality for the deliverables and the deliverables itself. And here we will look at some data samples and some functionality which is critical in today's working environment if we want to get the data fast, efficiently, and with a high quality and precision. So the GX50, the GEDO GX50 scanner system has a feature that it produces very coherent and very homogeneous point cloud data. So this is a feature which is really extremely welcome in the railway industry, that we have really very stable and very smooth data. So, and also from the visibility point of view, it covers, as Stefan already mentioned, that it covers the full view, so to say, from the scanning point. So we get all the data in the view. So as you can see in GEDO Scan Office, we can look at this data in different perspectives. As you can see, the quality is extremely good and high. It's also, if we are in the tunnel environment, so what was not possible before, and what it becomes possible, we can see clearly the bottom part of the track. And knowing some of the tunnel installations, we know that there is sometimes the drainage channels between the rails, and these have to be measured or scanned. And with this new GX50 system, this becomes possible. So we can document the drainage channels not on the side, not only on the sideways, but also between the rails. Going into the railway specific functionality, the GEDO Scan Office software is known for being really built for the railway industry, and when we think about railways, it's not just the two lines. So when we think about railways, it's full parametrical data of the rails. It means the left and right rail. Both are measured at the running edge position for the horizontal part, and top of the rail is for the vertical part as well. This data is accommodated with information about the track cant, super elevation, and the gauge. So this is nothing very simple. What we can think that this is just the two lines. No, this is not two lines. This is a quite complex data about the rail. And what's important that it's matching with the track measurement regulation. So what is more important is that using this track data, we can run multiple track measurements along the track. So going along the chainage, going in 3D dimension, we can take any information next to the track, and either it can be from the center line or it can be from the nearest rail. And basically we can grab any object next to the track and check the dimensions or offsets. So it's either perpendicular or with an inclination. So this is really valuable functionality from design point of view. I mean, if we are thinking about track designing and realignment, this is a really crucial functionality to make just check on the spot, see if the alignment changed in few centimeters, what it will be the effect on the clearance with a neighboring object. So also point registration or data registration is crucial when we want to add measure data into the project as as-built data. So we can just register new signal, existing signal positions, existing track installation position, like special signaling installations, so it can be some structures next to the track, and this will support the design process. Going from the track measurements, track specific or rail specific measurements, we move forward with another productivity tool, which becomes even more faster and more accurate with the new system. This is track extraction functionality, and with track extraction functionality, we talk about saving time on additional measurements, and what it means that if we measure the station, if we measure the scan, or we do the scanning of the multiple track installation, it means that we need to measure just one track, and the neighboring tracks can be automatically detected by fitting the rail shape and extracting the precise track position. So it's again, we talk not about just extracting the simple line, we talk about extracting the parametrical data, and it will basically create the horizontal and vertical track real position at running catch and horizontal, and at top of the rail for the vertical position. So this is a time-saving tool, very efficient. So we don't need to block the track. If we are in the stations, we can freely overcome some places where we have the standing rolling stocks and do the extraction using this functionality. Overhead lines, overhead line extraction is also functionality. It's about extracting the cables and staggers. So it doesn't matter if we are in the planning phase, in design phase, or we are thinking about maintenance of the overhead lines. The first thing what comes is the scanning and extraction of overhead line position, so where they are now. And with this functionality, we're able to trace and automatically detect lines and also extract the stagger position, so we get a report, a detailed report, and also deviation report, how the lines are fluctuating along the main line, and also we get a 3D position of the cable and staggers, so the cable mounting position and cable itself. So this data can be further reused both for the clearance analysis, for the further design applications. So it becomes a good data set for multiple use. Another thing, another very strong application, very broad application, what we're facing in railways is the clearance analysis, and GEDO Scan Office. It's really being strong hold of this feature. For many years, we have been improving this functionality over and over, and what shall we say, that clearance analysis is not just running the profile along the track and finding the collision places. The clearance analysis today is a much more complex approach, because many authorities requesting to run clearance analysis in a dynamic way. That means that we need to know not only the 2D shape of the train, but we need to think about the complete train, or wagon and train, and think in a way that we have to take care about the curvature of the track, and with the dynamic clearance, as you can see, the train, the envelope is extended depending on the curvature, and with extensions, or the throats in the middle and the end, depending on the length of the wagon, of course, we get a much better answers on a collision. So it's much more detailed and much more transparent, because with extensions we really pinpoint to the hazard positions, whereas with the 2D clearance we might miss some of the points, especially on the narrow radii areas. We could potentially miss those hazardous areas, but with a dynamic clearance and with a good train definition, we are able to pinpoint exactly where is the problem. And also, as a result, we get very good clearance analysis check, including the point cloud data. We get a full report with a maximum infringement. So with a single click, we can see immediately which spot is basically creating a trouble or blocking the traffic. And this can be also kind of work order for the maintenance, for the safety maintenance. So this is functionality really powerful. Also, we support country authority-specific dynamic clearances based on special rules and regulations. So this is not just a wagon definition. It's much more complex formulas and equations for calculating the front rear offset of the train. So this is clearance analysis can be in the design as well in the design, in the construction phase, and in maintenance phase. Use it as a really good tool to monitor the clearance. As clearance analysis is completed, of course, the next step is to get the documentation, and the documentation is both the polarized or the point cloud. So we get infringement point cloud separated from the main point cloud. We get a vectorized section data for the documentation, and then the final outcome is the 2D drawings with a precise location of the infringement and all the dimensions. So we see the horizontal, vertical dimensions of the infringement, exactly at which change this is happening. So this is fully automated process. So no human needs to think about anything in this way. So everything is automated, and we get the result in automated way. So this was more or less the overview about how the data from the new system is usable in the overall GEDO scan platform, about these procedures and deliverables. And we can go then to the summary. So what is important about the GX50 laser scanning system, what we always emphasize, is that it's railway specific. So it's built for the railways, independently on the gauge standard, independently on if it's a flap track or it's a ballast track, it's a tramway, it's a metro, it doesn't matter. So with today's possibilities, we can build any configuration based on GNSS, total station, EMS solution, and cover 360-degree view area with highly flexible mission planning, with highly flexible system accuracy. And at the end, with this approach, we are able to save the overall measurement lifecycle cost. So to summarize all the applications, as I mentioned, those 4 groups. So the main, probably the most important thing is here the clearance check. So it's either the structural clearance check or it's the rolling stock clearance check. It can be, as I mentioned, in pre-design, design phase, or it's during the construction or during maintenance. So it's a highly used, so to say, highly spread application, I would say. Then we talk about other applications like as-built check of the existing track, as-built check of the overhead lines, monitoring of checking of the materials before and after the construction, so sediment, and asset data collection for the CAD and GIS system.
Thank you very much, Linus. So now we're going into the last part of this presentation, which is covering questions that you might have. We had a few already in the chat window. If you have more questions, please feel free and type them in, and we'll cover them now. So the first question we got was, we talked about the different configurations, butterfly, 90-degree, 80-degree, and the question is, how long does it physically take to change from a 90-degree orientation, for example, into a butterfly configuration?
Yeah.
So what is the time it takes?
There is basically no time involved. So we have, as you saw from the presentation, Each scanner head has 2 clamps, so each scanner head has one clamp for horizontal adjustment, or horizontal angle adjustment, and another clamp for the vertical angle adjustment. And it means that we have to release 2 clamps and just adjust the angle of the scanner to the fixed position. So there are 2 fixed positions for each scanner, and I would say it will take 1-2 minutes to adjust.
Okay. And then in the field software, we have the different modes to select.
In field software, we should not forget just to change the scanner head position.
Yeah. Okay. One question is also here, the previous system with the Trimble TX8 laser scanner in combination with the GEDO trolley system, how is the GEDO GX50 different from a TX8?
Yeah, the main difference here is the productivity. So basically with the GX50, with GEDO GX50, we are limitless on the speed, so we can just go much faster compared to the previous system. On the accuracy side, we are maybe slightly below, but I mean, accuracy is not always as critical as the productivity. And I mean, this is just, of course, this is based on application. So we have always to think, okay, what is application and what's the system configuration we have to take.
Okay, then we have a question around the measurement range of the GX50 system.
Yeah, so the measurement, the practical measurement range in railways, it's around 30 meters. The practical what is used, but the range with a GX50 can go up to 80 meters.
Okay, then we have one more question. And this is how the absolute geodetic data is generated to objects adjacent to the track, affected by the track inclination, or is all data relative? I think I can answer that question. It's basically the trolley system gives you the exact, in combination with the geodetic system, gives you the exact 3D position of the trolley on the track. So you have the inclination sensor that's part of the trolley system. So you know exactly what the position is and the inclination coming from the trolley system, right? And at the same time, you measure scan data.
Yeah.
And that scan data is referenced to your known trolley position.
Yeah.
So at any point, if the inclination changes, for example, this is reflected in your scan data when the scan data is processed or pre-processed in the GEDO scan office software.
Yeah.
So the answer is yes. If you combine it with a geodetic system, you always have an absolute reference point cloud.
Yeah.
The exception is you don't use a geodetic sensor and you are in the pure relative mode.
Yeah.
In the pure relative mode, of course, you don't have that orientation.
Yeah. Just the inclination.
Correct. So I think as of now, this is the last question we got. We still have some time, so if you have additional questions, please feel free to type them in. If you have questions that you want to send us via email, on the last slide, actually we have our info railway email address. Please feel free to reach out and ask any questions you might have. So I'll give it another few seconds. There's one question available about availability. Is it available now? So the public announcement was made last week, July 12th, and the system is available. Yeah, that's correct. Okay, it seems there are no more questions. Thank you very much for joining our webinar today. Again, we are looking forward to hear from you. Thank you very much for your attendance and talk to you soon. Thank you.